go to the uh, presentation mode. Okay, can you see this figure? I need some answer. Can you see?
Yes, sir.
Can you see the presentation?
Yes.
Yes,
Yes,
sir.
sir.
Okay. If anybody has problem, just let me know. And I'm audible, right?
Yes, sir.
Okay. Now this is basically the fast drawing. What you will be doing is the tool head of a shaping machine. Okay. Now this is a shaping machine basically. This is an inter shaping machine, and purpose of the shaping machine is to make plane surfaces. Now this is a vise. Okay, this is a vise where we generally job is held here. Any say square section of the job. Suppose one surface I want to plane it. This is the tool. Okay, this is the cutting tool. Now this is called the ram of the shaping machine. By some mechanism. By the way, how much class has been done in your kinematics? Have you come across with the quick return mechanism or ball and ratchet mechanism? Any class on kinematics of your section?
So yes, sir. We have done two classes on kinematics.
Two classes. Have you had a quick return mechanism? The name of quick return mechanism?
No, sir. We have the basic idea about kinematics analysis.
Okay. And ball and ratchet mechanism? No, no. Okay. Anyway, forget it. Now, these two mechanisms basically used in uh, uh, shaping machine. Okay. Let me do one thing. Put the video off. Now, one is that quick return mechanism is placed somewhere here, and ball and ratchet mechanism is placed here. Now, see what a shaping machine does is the tool is fixed here, okay, and it can when it advances in this direction, forward direction, it removes material, okay, from the surface of that thing. So naturally, it has to give a to and fro motion. This to and fro motion is being given by the quick return mechanism. Okay, and why we call it a quick return mechanism? But I mean that tool will move past the job and then it will stop here. Then it will return in this direction and then again it will cut. Now you can understand that the forward motion, because cutting tool edge is something like that. That forward during the forward motion only cutting takes place. The backward motion is a idle motion. Okay, that is a lost time for the machine because it's not doing any productive work. Now, quick return mechanism is some mechanism. The RAM will move to and fro, but during the forward motion, it will go slowly. During the backward motion, it will move fast. Okay, that's why it's called quick return mechanism. And there is another mechanism, because if I do the only quick return mechanism, it will move backward and forward, but then problem will be on the surface of the job only one portion will be removed always. Okay, now suppose there is a job which is having a width. Now if we have to plane the entire width of the job, then what we do is we have to give a feed motion here. Once one cut is done, it come back, I give a feed motion here on the sidewise, then there is a slight displacement of the tool on the sidewise, and then next cutting motion takes place. Now this is done with the help of a ball and ratchet mechanism. Okay, this is called the table of the shaping machine, on which sometimes we, if it is a bigger job, instead of the vise we can put on the table itself. Okay, this is called the tool post. Okay, this is called the tool head. This is down feed handle. Okay, and this is a stroke controller. The stroke of the RAM, or in other case tool positions, how much it will move backward and forward, that can be controlled with the help of this stroke indicator. Okay, and there are some other parts, but our concern will be on, your concern on the during the drawing part will be this portion. Okay. Now let us come to the next page. This is the tool head, basically a shaping machine. Okay, now the tool is placed here. There is a, you can, elliptical slot is there. There is an elliptical slot here. I place the tool vertically in this direction, and then this bolt head I can rotate in the clockwise direction. If it rotate clockwise direction, it will move inside. And what will happen, that it will press the tool head at some position so that it will be tightened. Okay. Now this box is called the clapper box. As you see, it is called clapper box, and this is called clapper block. The inside one we call it a clapper block, or sometimes we call it a swivel plate. Okay. Now by rotating this one, this handle, there is a nut inside. Okay, this entire thing is the acts as a nut. Now if I rotate this one, because this is fixed, the bolt cannot move, the nut will move. So what will happen, I can move this one, the tool head, up and down. Okay, that means positions of the tool I can adjust vertically with the help of this one. At the same time, the angular position I can move. There is a elliptical slot here, you see, and there is a bolt here. Now I can release this bolt so that it will be loose, so that I can move this one about this axis. About this axis I can move this clapper box, so it can have a angular positions. Okay, I'll show you something more. And this is called a swivel base. So with the help of this screw handle, what I can do is I can have a movement of this one. Now what you have to do is, you have to draw tool head, means you have to draw this entire thing, in orthographic projection drawing, either assemble or detail parts. Okay, any questions so far? Okay, now how can I swivel it? You see that this we have done the swiveling. Okay, I have made this one angular with respect to the vertical axis by positioning this nut and bolt. Okay, and another thing. Okay, let me do one thing first. Any question about this so far? No.
Sir, is the shaper mechanism, means this shape is used for making grooves or like
Okay,
clearing a
grooves,
surface?
planing surface also. I can make
Okay.
a surface plane, absolutely plain. That also you can make. I can make groove. I can cut V grooves.
Okay.
So many applications are there for shaping machine. Let us say one video. Okay, for shaping machine.
Sir, if you can zoom that, means maximize that.
Ah, what?
So you can
What?
maximize that. Maximize that. Yeah.
Okay. See, this is the movement is shown, and this is the RAM movement. Okay, of the shaping machine. This is the tool I am talking about. And see how the material is being removed. See, this is the way material is being removed, and at the same time I have to give a feed movement on the width side. This is the handle. They have shown some exploded view of this. Now this is the clapper box. I can lose this one and I can tilt it this way and that way. Okay. This is the tool head. By this movement, actually, I press the tool against this one. This is called washer. This is called swivel plate or clapper plate. And there is a curvature here, you will see. And there is a pin. By this pin joint, this is being attached here. See, there is a countersunk hole here, okay, and there is a pin here. About this pin, this can rotate. This is the tool placed. When I okay. So I hope you can understand the function of a shaping machine. Sorry. Now, what is our first job is to study the tool head of a shaping machine. There are some other figures also given here. Sectional views of is there. Okay, these are the different members of a shaping machine. Okay, tool head of a shaping machine. Now, this sometimes we call it a drag release plate also. Okay. Now you see that this nut, okay, there is a countersunk here. This head comes here, okay, and this is fixed to some point. Now about this center point, this is the side view, this is the front view. You can see that about this center point, this entire thing can rotate. If I release this one, okay, and this bolt is placed here, okay, and it is attached to the some back plate. Okay, now what we do is we release this one a little bit. Then what will happen that there, since this is an elliptical gap, I can rotate this one about this point. Okay, so that I can make it in an angle, and if I make this one in angle, this will hold basically the drag release swivel plate and the tool hold. So naturally tool can be swiveled. Okay, so this is one item, and one clamping screw is there, and this screw is called swivel pin. This is the swivel pin here, placed here. Now this item, this swivel plate or clapper box, what is called, this actually, see that this distance is equal to this distance. Okay, there is a, see, if you see the sectional side view of this one, that means there is some projected part here of this item. Okay, and the distance between this projected part is this one, which is actually accommodates this part, this entire part, and this hole matches with this hole, with these two holes placed here and here. Okay, now once they matches, I can put the pin through this, and if there is a pin joint, that means rotation is possible. So what will happen, that this can move about this pin, it can move up and down in this way, and this is required during the backward motion of the tool, because backward motion of the tool, what will happen, that that clearance portion of the tool basically fouls with the surface of the job. Okay, so if there is a swiveling, then no scratching will be done on the job surface. Now this thing actually goes here. This is the tool holder. Now this bolt I can adjust to and fro in this side, and there is a washer here. Okay, now we place the washer here, the tool is placed here. Okay, vertically through this page, and I can tighten the tool with the help of this nut, so this bolt. Okay, so that tool can be fixed, and this entire thing, this thing is attached here basically. In this place it is being attached, but this, you see there are two diameters here, this diameter and this diameter. So this will fit here and this fits here, so it's projected in this direction. Okay, so ultimately what we get is there is a figure. This is the same figure is being shown here. Okay. Now this is the actual thing. Okay, what you have to do, whatever drawing has been given here, this point, this item is there, this item is there, this item is there, and there is a swivel plate in between these. These four items are shown in the drawing. This frame is not shown here, and these two pins are shown here. So I said four items, 1, 2, 3, and another one in between that. So those four items are these four items, but this bracket, this plate, back plate is not shown there. Now, so these are the four items, 1, 2, 3, sorry, actually 5 items. There will be these two constitute 5 items basically. Okay, now what is your first drawing problem is you have to draw the assembled view of this one. Okay, two assembled views, one is a front view, another is maybe top view. Okay, so all the dimensions are given here, and one of the views should be sectional view. Okay, any question so far? Either you can draw with the help of AutoCAD, or what you can do is in the first drawing as such, you can take a A3 sheet, and you can do the drawing at home by sketch. I mean, you just take scale, ruler, and pencil and do the drawing, but dimension should be kept like this. You take these dimensions and draw the assembled view of these items. Okay, and also give the dimensions. Any question?
Sir, assembly view means, sir, the different parts we have to show.
I haven't shown the assemble view here. Assemble view I haven't shown here. See, you have an idea of engineering drawing, right? So you know that how this object looks like. Now, what you have to do is the assembled view will be something like this actually, but not exactly because dimensions are not given here. This is the assembled view sort of, at least one side view. This is the toolet. This is the thing. You have to draw till this and with these two pins. Don't draw this. These should not be included because you don't have the dimensions for this plate, not given. Okay, dimensions are given for this one, this item, or entire dimension for the tool head, this one, this clamping screw, these dimensions are given, and there is another swivel plate which is inside this one is given. Okay,
Okay, sir.
you got it?
Yes, sir.
Actually, you see, what you have to do is you have to draw two views of these items, this item, this item, this item, this item. This is not given, and this pin, and there will be another pin projected here, small pin. Okay, so you have to take a. What you do is you take this as the front view. Take the front view and top view from this side. This is your front view, this is your top view, and you can make, say, front view, sectional view. Top view, no section is required, but dimension for all these already given. I'll send you this Word file to you. So what you do is you take a A3 size sheet, make a nameplate on your table at home, and take a ruler, or you have the T-square also, set square also, with the help of set square, so that try to make sure that horizontal lines are more or less horizontal, vertical lines are more or less vertical, and you draw the two views. One is front view, this should be the front view, and another one is the top view of this toolet of a shaping machine. Okay, with all the dimension taken from this Word file. Okay, all the dimensions are given, and then you take a photograph of that one and then send it to me. And by the time you try to find out how to draw AutoCAD. Once you are master in AutoCAD, the next drawing you can do with the help of AutoCAD. Any question?
Sir, if I draw this drawing in AutoCAD, does you any problem, sir?
What?
Sir, you told, sir, this first drawing we have to make in A3 sheet. So I tell you, sir, I know the AutoCAD. So, sir, I can draw in AutoCAD.
What is your name?
Sir, my name is Apurva Das.
Huh?
Apurva Das.
Apurva Das. Okay, you can do the AutoCAD drawing, but
Okay, sir.
nobody else, because I'll get only one drawing. I'll get only one drawing from everybody.
Sir, I
So
can
Apurva
try
is drawing
also.
AutoCAD. Rest and the first drawing I want that everybody should draw on their own handwriting.
Sir, I can draw only AutoCAD.
Pardon?
Sir,
Huh.
I can
Yes.
try it also in AutoCAD.
Don't try. Try next time. Next
Okay,
drawing
sir.
onwards.
Actually, sir, I know also AutoCAD. That is why I am saying that if can I try that AutoCAD? If I fail, then I can try it on my drawing board and paper.
No, okay. In the first drawing, I said even Apurva, I want that everybody should draw it on their own. I mean, by hand. That will be better.
Okay, sir.
Because see, when you draw, in fact, in our new course syllabus, actually, we'll coming going back to actually again manual mode. See, AutoCAD drawing, its problem is uh, uh, there is some lacking. I mean, all the drawing if you do with the help of AutoCAD, by drawing in hand, you know the intricacies of the drawing and how the object looks like. Conception becomes clearer if you do little bit manual drawing. Anyway, that is not the issue here. But fast drawing, I want that everybody do by hand sketch. But try to do with the help of set square and other things, so that horizontal lines and vertical lines remains vertical as far as possible, or horizontal. Okay, and take the dimension from here. And if you have any question now, please feel free to ask. This is all the dimensions are given here. Okay, as per the dimension you have to draw it, and you draw it 1:1 scale. Okay. See, there is a taper pin here, so that I can press it here from this side, so it will be tight. And 1:40 taper. This tapering is given 1:40. You know what is 1:40 taper? That means there will be a reduction in the diameter by 1 if I go in 40 as per the length. I mean, that means tan theta is 1/40 actually. This is the way we give the dimensions, I mean tapering, because it's easier to measure tan theta than any other angle. So all the dimensions are given here. So you do it. You see the two lead dimensions are given here. You don't have to draw the tool.
So submission.
Pardon? Say.
Submission date.
I cannot hear you.
So submission date.
Oh, next week. Always.
Okay, sir. Okay, sir. Okay.
By next week. Before the beginning of the next week. And see, you have got another thing I must mention, that you have got the link through my mail gautam.pohit at jadavpuruniversity.in. Okay. So you send your drawing soft copy on this mail only, not my gpohit other mail. I don't see those mails. Okay. So by Tuesday morning it should come to me. And if you have any question, feel free to ask now or anytime. Do you have a WhatsApp group?
Sir, you can create a Google Classroom, so it will be more convenient, I guess.
Why?
Sir,
I mean-
means we can directly submit the pictures there, and you can directly get them. Means it will be convenient for you as
Okay, maybe next time when you will be conversant with the AutoCAD, I'll do it Google Classroom, so that I can watch whether you are doing it on the computer on your own or not. That will be better, right?
well. Oh, yes, sir. Okay, sir. Okay.
Okay then. Okay, one other thing, let me see. See, 21%, 20% has come. Okay, so how many are you here? 25.
Sir, 26. Sir, 26.
So 6 is absent. Should I start roll calling?
Yes, sir,
In the next class, I will do that. Okay then. So since you don't have any other question, I am finishing it. Okay. Thank you.
Okay, sir. Thank you, sir.